In section 4.6, we're dealing with slope-intercept form. Slope-intercept form is one of, if not the most important type of linear equation. So, we've got a couple warm-up problems that we're going to actually do together to make sure we're all in good shape moving into the lesson. So number 1 and 2 ask us to find just the y-intercept. Now remember, to find the y-intercept, it means that x is 0. So we can just make the x term go away. So if I make the x term go away, my y-intercept in number 1 is just 2, which is technically the ordered pair 0, 2. In number 2, looking for the y-intercept, x is 0, make the x term go away, we have an equation negative 3y equals 12 remaining. So we're going to solve for y by dividing both sides by negative 3. So it ends up with y equals negative 4 as our y-intercept, which would be the ordered pair 0, negative 4. We're actually going to skip numbers 3 and 4 for now and go straight to numbers 5 and 6, which ask us to solve each equation for y, which means we need to isolate y using inverse operations. This is going to be a critical skill. So if I want to get y by itself, we're going to go back to our roots of circle the variable term that we want to get alone, okay, dotted line through the equals sign, we want to channel all of these thoughts. Well, if I want to get 2y alone first before getting y completely by itself, I've got to move the 4x. Well, the 4x is connected through the addition-subtraction bond, and because it's technically a positive 4x, I need to subtract 4x from both sides. Now, I've got a 2y left on the left-hand side equals, I cannot put 10 and negative 4x together and make a new term. I can't do this subtraction. So they're just going to become next-door neighbors because they are not like terms. And we like to have our x's, or our variable terms, in front of our constants. So that means when I rewrite this, instead of writing it as 10 minus 4x, I'm going to put the negative 4x in the front, and then that 10 is technically positive, so it'll be negative 4x plus 10. Now to get y completely by itself, I need to move the 2. So I need to divide both sides by 2. Now when I divide both sides by 2, technically speaking, the negative 4x is getting divided by 2 and the 10 is getting divided by 2. So what I have remaining here on the left-hand side is just y equals, I'm going to show that both of these terms are getting divided by 2. So negative 4x divided by 2 plus 10 divided by 2. And now because we can do negative 4 divided by 2 and 10 divided by 2, we need to actually go ahead and do that. So it'll give us a final answer with y by itself as y equals negative 4x divided by 2. Negative 4 divided by 2 is negative 2. So we've got negative 2x plus 10 divided by 2 is 5. Okay, so we solved the equation for y. In number 6, if we solve for y, dotted line through the equals sign, I want to get y by itself. Well, the whole y term is already alone, so that's good. So let's completely isolate y now. So in order to do that, we're going to divide both sides by 6. And just like the previous problem, because the 3x and the 2 are both getting divided by 6, I'm going to show that. We have 3x over 6 plus 2 over 6 equals y. And we're going to simplify. 3 over 6 simplifies down to 1/2. So it's technically 1x over 2 plus 2 over 6 simplifies to 1/3 equals y. And now I'm just going to write it where I'm going to flip the whole thing around and write y equals. What I can do here, because I have 1x over 2, I can just kind of write this fraction out in front of the x as a coefficient. We're going to boost the x off this side. I'm going to write it as 1/2 x plus 1/3. Okay, you'll want to definitely do that in this lesson and moving forward. Okay. So our goals for today are to be able to write a linear equation in slope-intercept form and to graph a line using slope-intercept form. And we're not going to do the whole entire lesson in one video. We'll split it into 2 different videos. All right, so we have seen that we can graph a line if we know 2 points on the line. Okay, so we graphed already using x and y intercepts. Another way is to use the slope of the line and the point that contains the y-intercept. Therefore, it's called slope-intercept form. Okay? So here's a model that says graph the line given the slope and y-intercept. So the slope is -2/5. The y-intercept is 4. So what we need to do is we need to start off with plotting the y-intercept. So the y-intercept is 4, so we're either going to just say, okay, go to 4 on the y-axis, or you can look at it as the ordered pair 0, 4. Then, because our slope is -2/5, that slope refers to rise over run, or change in y over change in x. So from the y-intercept, we're now going to walk along those city blocks, going north and south, east and west, to then represent a change in y of -2, meaning go down 2 blocks, change in x of +5, go right 5 blocks. Then we plot the point where we end up. Now we have 2 points and we can draw our line. Okay, so the first 2 examples we are doing just that. Graph the line given the slope and the y-intercept. So we're going to start off by plotting the y-intercept. Okay, so this is first task. So the y-intercept is -3. So we go down 3 on the y-axis. Now, our slope is 2. So step 2 is this one. So because our slope is 2, it's a whole number at the moment, and we like slope as fractions in terms of trying to graph. So I can write a whole number as a fraction by writing it over 1. So 2 over 1, and I'm going to write right next to it, rise over run. So, from my starting position at the red dot, the y-intercept, I'm now going to rise 2 blocks and run 1 block to then plot my next point. So I need to go up 1, 2, turn the corner, run 1. Okay, so both of them were positive. So rise of +2 means up 2, run of +1 means right 1. Now technically that's enough to make a line, but I'm going to continue to rise 2, run 1, so I have more points on my line. So I'm going to go up 2 blocks, right 1 block. Up 2 blocks, right 1 block. Up 2 blocks, right 1 block. Now I could also go the total opposite direction. So if I go back to my y-intercept, instead of rising 2 and running 1, +2 and +1, I could go down 2 and left 1, because technically that's 2 negatives. Down would be a -2, left would be a -1, and a negative divided by a negative is still a positive. Okay, so you can always go opposite in both directions to then continue your line with these points, okay? And especially given our situation, we want to put as many points on our line as possible. So now that we have a whole bunch of points, we are going to draw our line with a straight edge, goes straight through, and we are showing that it continues on and on forever in both directions. Now we're going to do it again. Number 2, our slope is 2/3, our y-intercept is +1. So we start with the y-intercept. Our y-intercept is +1, so we're going to go to the y-axis at 1 and plot our point. Now, because our slope is 2/3, we're going to use that and walk the city streets. So m equals 2/3, and we're going to show rise over run. Okay, so starting from our y-intercept, we are going to rise 2 units and run 3 units, both positive. So that means we go up 2 units, turn the corner, go right 3 units, and plot the point. Go up 2 units, right 3 units, plot the point. Rise 2, run 3. Okay, and again, while this slope is positive, 2 negatives also make a positive. So if I go back to my starting position, okay, I can go down to left 3. And it's still going to continue with that line. Down to left 3. Is that 3 or is that 4? It's hard for me to see. 1, 2, 3. Okay, notice all these points do lie in a straight line. Okay, so we've got a whole bunch of points, and we can go ahead and make our line with our straight edge, arrows on the ends. Oop. Those are pretty obnoxious arrows, huh? Okay, so in these two problems, we were directly given the slope and y-intercept. It directly stated it. Now, we're going to talk about, well, it's not going to always be directly stated. We need to know what slope-intercept form of a linear equation looks like, and then we're just going to state ourselves, based on that equation, what the slope and the y-intercept are. So, if a line has slope of m and a y-intercept of b, the line is described by the equation y equals mx plus b. So this is going to be your best friend, slope-intercept form. Okay, so any linear equation, any one, can be written in slope-intercept form by solving for y, which means get y alone and simplifying. In this form, we can immediately see the slope and the y-intercept. Okay, and then as a result, we can quickly graph a line, just like we did in the last two problems, using that slope and y-intercept. Okay, so if we have y equals mx plus b, the slope is the number in front of the x, whereas the y-intercept is that constant at the end that's by itself. Okay, so in our next series of problems, we are going to be given the slope and the y-intercept, and we need to simply write an equation inserting the slope in front of the x and the y-intercept at the end as the constant by itself. So if it says write the equation that describes the line in slope-intercept form where slope is 1/4 and the y-intercept is 4, the 1/4 is the slope, so that goes in front of the x. The y-intercept is 4, so that goes in for the b. There's our equation in slope-intercept form. So number 3, says write the equation that describes the line in slope-intercept form. So if the slope is -9, I'm going to label that as m. The y-intercept is -5/4. That is my b. So it's good practice to start writing y equals mx plus b. And now just simply write your m, your slope in your m slot, your y-intercept in your b slot. So here's our equation. Y equals, m is -9, so -9x. B is -5/4, so -5/4. And that's it. Number 4. Your slope is 2, that's m. The y-intercept is -4, that's b. We need to start by writing y equals mx plus b, and we're going to put the slope in the m, the y-intercept in the b. So y equals, m is 2, so 2x, plus b, our y-intercept, is -4. So instead of +4, it's going to say -4 since it's negative. You do numbers 5 and 6. All right, so here are our solutions for number 5 and 6. Number 5 should say y equals -12x minus 1/2. And number 6 starts off as y equals 1x plus 0. But that's kind of what we consider redundant. If there's a 1 in front of a variable, it doesn't need to be written there. If there's nothing in front of it, it implies 1. And if there's a plus 0, well, that doesn't really mean anything, so we don't need that plus 0. We just need to also acknowledge the fact that if there is no number being added here at the end, that there is a y-intercept of technically 0, that b is 0. Okay, so these two are equivalent. This is more direct in telling you directly my slope is 1, my y-intercept is 0, but this is how you will see it actually represented. Okay. Number 7, we're asked to write the equation that describes the line in slope-intercept form. So because we want an equation in slope-intercept form, we need the slope and we need the y-intercept. So if we locate the y-intercept, we need to go to the y-axis and determine at what value it crosses through. Well, it's right here is our y-intercept, and our y-intercept is 3. So I'm going to literally write b, which is the way that we represent y-intercept, b equals 3. So we've got the intercept part. Now we need to find the slope. Well, if I have a line that's graphed here, I can use my rise over run approach to go from one perfect point to the next, okay, which we do have 2 perfect points here, in order to determine what the slope is. So if I start from my left perfect point and travel to my right perfect point, only going up, down, left, right, we can then determine what our slope is. So remember, m equals rise over run. So we want to rise first. So to go from left to right, I need to rise up 1 unit. So my rise is 1, positive 1, over. Now I need to turn the corner and travel to the right 2 units. So my slope is 1/2 because we rose 1 and we ran 2. Now I have my m and my b, and remember our slope-intercept form is y equals mx plus b. So we're going to insert 1/2 for m. So y equals m, which is 1/2, times our x, plus our y-intercept, b, which was 3. And now we have 2 more problems in this part of our lesson before we stop. Number 8 says to write the equation that describes the line in slope-intercept form. I didn't want that to be red. We'll go back to our yellow. So we want slope-intercept form. So it means we need to find slope and the y-intercept. Now here's the problem. Based on the information that we have here, it says the slope is 2, so that's good. We have m. However, we don't have the y-intercept. We have just an ordered pair, 3, 4. Now, if I were to label that with some letters, variables, this is an x and a y. So if I think about my equation y equals mx plus b, we want to try to be as literal as possible. We have a y value, it's 4. We have an m value is 2. We have an x value is 3, but we don't know b. But that's what we need yet. Okay, so we're going to plug in the information that we do have and then solve for b. So let's take a look here. So we have y is 4. Let's use a different color. Come on. So y is 4 equals m is 2. Okay, so 2. M gets multiplied by x, and I know that x is 3. And then plus b, which we don't know. So now we need to solve for b. So I need to do the 2 times 3, follow some PEMDAS. That's going to give us 6. So 4 equals 6 plus b. And now if I solve for b and I get b alone, I would need to get rid of the 6. And I would need to subtract 6 from both sides. So that's going to leave me with -2 equals b. Therefore, we would say b equals -2. Okay, so we've got our y-intercept that we need. We have the slope that we need for our slope-intercept form. So now we can actually substitute our slope and our y-intercept in. So now we have our equation. Y equals m was 2. So 2x plus b, but our b was -2, so -2. Okay, so for slope-intercept form, we always need an m and a b. And sometimes if you don't have it, you need to do some other algebra in order to find one or the other. Number 9 is the same exact type. It says a line has a slope of 8. So we've got our m. That's good. We have an ordered pair, -3, 1 is on the line. Well, that's not a y-intercept, but that's just an ordered pair, x, y. Write the equation that describes this line in slope-intercept form. Okay, so we want slope-intercept form. So we're going to start off by writing y equals mx plus b. We need slope, we need y-intercept. We have slope, but we don't have the y-intercept. So we're going to plug in the information we have in their respective variables. So y is 1 equals m is 8 times x, which is -3. Be careful, put the negative in parentheses there. Plus b is what we don't know. So we're going to do the 8 times -3, going over here. So we have 1 equals 8 times -3 is -24. Drag along the plus b. And now let's solve for b. So if I circle b, in order to get b alone, I need to get rid of this negative 24, so I'm going to add 24 to both sides. So that means that 25 equals b, aka b equals 25. So we now have our slope, which was 8. We have our y-intercept, which is 25. So now we can go back to our slope-intercept form. Y equals mx plus b, and substitute in. So we only plug in m and b. So y equals, m was 8, so 8x plus b is 25. So y equals 8x plus 25 is our equation in slope-intercept form.